if you do something wrong in the basics, what you add on top will always suffer from your mistakes you did in the basics. And here it's sometimes very simple. So if we think about, for example, sampling procedure, as with precision, we target afterwards that we want to have precise results. Doesn't matter if you want to have precise results for the analytics or if you want to have precise results for recommendations, but we need to have precise results. And therefore, sampling is a fundament of everything which is coming later.
Hello, everyone. Welcome to this episode of the Feed Science podcast show brought to you by Weisenetics. I am Wilmer Pacheco. I am an extension specialist and associate professor in the Department of Poultry Science at Auburn University. And we are dedicated to bringing you the latest insights and discussions in the feed industry. So get ready to expand your knowledge and stay ahead with today's episode. And today I'm joined by Dr. Markus Wiltafsky. Dr. Markus has extensive experience in animal nutrition, feed ingredient evaluation, and precision nutrition strategies, with a strong focus on improving feed quality and nutrient utilization. And in today's episode, we will discuss the current challenges and opportunities in precision nutrition, the role of ingredient quality control, the practical applications of NIR technology, and the future of data-driven nutrition programs in the poultry and feed industries. Hello, Markus. How are you doing?
Yeah, hi, Wilma. Nice to be here.
If you don't mind, Markus, could you please share some of your experience with our audience?
Yeah, sure. So regarding my background, by training, I studied agriculture here at the University of Munich in Weinstefan. I focused there on animal nutrition and continued as well with the PhD thesis. So at that time, for example, part of my thesis had been amino acid requirements for isoleucine, leucine, valine in piglets. So that was more or less 20 years back. Already at that time, it was a good topic. Today, it's common knowledge. So there, after that, finishing my PhD thesis, I joined in 2009 Evonik. And since then, I'm with the company. My first position, I was responsible for technical activities in Eastern Europe. So there I traveled a lot in Eastern European countries, explaining the services, the products we have, and realizing as well that what you learn at university sometimes looks a little bit different in the real life. So that was really nice for me to see how to translate what we learn at the university into practical concepts and to apply it afterwards as well in daily routines. And this is completely different compared to sitting on your desk and believing you are now having the latest recommendations and everybody shall use them. And then you go out to the markets and you realize, oh, there are some other challenges as well, and maybe they are more urgent than what you did in your PhD thesis. So that was quite nice for me. I did this for a couple of years. And after that, I joined a more internal position here, where I'm looking more deeply into the services and how we can help the industry to become more precise, to reach, as we have it in the outline, this precision nutrition. And that's a great task. And I can see that we are able to make progress here, so that we are coming closer and closer, but there's still a lot to do.
Yes. And that's one of the topics that we are going to discuss, like with you today, and is precision nutrition, because it has become a major focus in modern animal production. And I would like to know from your perspective, what are the most important factors that nutritionists and feed manufacturers must consider when implementing precision nutrition programs?
For me, it's always important to first check really the basics. So as if you do something wrong in the basics, what you add on top will always suffer from your mistakes you did in the basics. And here it's sometimes very simple. So if we think about, for example, sampling procedure, as with precision, we target afterwards that we want to have precise results. Doesn't matter if you want to have precise results for the analytics or if you want to have precise for recommendations, but we need to have precise results. And therefore, sampling is a fundament of everything which is coming later. So if you talk about then ingredients in sampling, you can do a lot wrong. And if you don't take a representative sample, afterwards you can have the best methods in place, you will end up with numbers which are not really reliable. And the same is as well true if you think about the requirement side. So if we're doing mistakes in estimating the requirements of the animals in the wrong way, then we will suffer afterwards. So therefore, what we try with precision nutrition is always to combine both things together so that we have got the best recommendations or in place, so that the requirements are as close as possible to what I try to achieve. Or if we are in different markets, for example, you can grow broilers in a live market where you sell them just as whole broilers. So then it's a different recommendations needed, for example, compared to if we are in the market where we sell breast meat. So therefore, we need to fine-tune as well the recommendations we are using to what we try to achieve in the company. And on the same side, we need to bring it then together to have the best data for the raw materials which we are using to prepare a feed which is as close as possible as well to what we calculated. So if we are doing here some errors, then we will fail, or we will see that we don't achieve what we tried to achieve.
Evonik Animal Nutrition is committed to ensure food security and safety while reducing the ecological footprint of animal farming. Its products and services use evidence-based solutions that seek to promote animal welfare and reduce reliance on natural resources. All this is underpinned by long-standing industry partnerships and deep customer understanding. Evonik's focus on efficiency, sustainable, healthy nutrition, and collaborations with livestock farming partners creates value for customers and consumers.
Yeah, excellent. And you know, like you are bringing like a really good point about like sampling, because I mean, like you can have like the best analytical methods, but if the sample was not correct, then you are not going to have correct results. But also, you know, like sometimes feed mills face like nutrient variability, and how does that affect precision nutrition? And maybe like, do you have like any advice about like how do feed mills need to consider this variability? Maybe like do we need to analyze more often ingredients that are more variable, or should we analyze about the same rate pretty much?
Yeah, that's a good point, Wilma. If we have a look on which raw materials are analyzed by feed mills regularly, so then we get at a high score. Usually we see a lot of soybean meal data, we see a lot of corn data. But other raw materials are more variable. So like meat and bone meal, poultry byproduct meal, sunflower meal, much more variable compared to soybean meal. So therefore, setting up sampling plans, it's important to consider which variation do I expect from which raw material. So this can be easily calculated. If you have got the historic data available, then you will see the variation in the individual ingredients. So therefore, you can anticipate as well which part of the diet variation is coming from which raw material. So therefore, if you see, for example, if you calculate a diet including meat and bone meal, just 3, 4, 5% of meat and bone meal, then it will make up already a big chunk of the variation in the amino acids, as these products are not really standardized. So therefore, it's then important to say, okay, I will use my lab capacities as well to have a closer look on those raw materials which are more variable, like the meat and bone meals. And then you are able to build up your own database, and it's important to work afterwards then with the data. So if we stick to the example of the meat and bone meal, we had once a project running here, especially on meat and bone meal, with a pet food producer. And there we could nicely see they were receiving shipments from 4 different suppliers. And all the meat and bone meal always went into the same silo. So there was no differentiation possible, as they just had one silo for meat and bone meal. Having a look on the data, we could easily identify that it would make sense to differentiate the deliveries based on the quality. Then you can have a look, for example, on the ash content or on the protein content, whatever is most variable, to separate it in 2 clusters. But therefore, you need to have afterwards then as well the possibility to handle it in separate qualities. So at that time, the company did not have another silo. So therefore, they made a business plan. They calculated what they would earn if they would have the possibility to split it in two qualities. And with the next enlargement of the company, of the facilities, they went for a second silo. So to have then the possibility at the reception point, do the analysis and decide should it be in silo A or silo B. To take out the variation, to make it more homogeneous, to have better data afterwards than in the feed formulation. So therefore, analyzing the data, having a look in the profiles and taking actions is really the most important part to come closer then as well and create raw materials which are more homogeneous. And here the solutions or options can be quite different depending on where you are. For example, if you are purchasing, if we stay with an easy example with the soybean meal, we know from the data sets that soybean meal from USA has got a nice quality. Usually it's showing us less variation compared to other sources. But if I do not have local supplies of American soybean meal, then it's nice knowledge, but it's not worth anything. So therefore, I need to have a look what is possible in my situation. And then if I'm not able to take out the variation by sourcing from reliable suppliers, then I need to take action afterwards in the feed mill to set up processes where I distinguish then the qualities. So this example with the different storages is a very practical one. It needs investment, yes. Then you need to have separate silos or separate bins, whatever. But it's possible.
Yes, yeah, and like one thing that you are mentioning is very interesting too, is like to understand that variability, because what I will imagine is like if you have two silos too, you are going to have like a smaller margin of safety for those ingredients because the variability is going to be lower. But also within the feed formulation program, you can decide what will be the best supplier, and based on that nutritional composition and the price that you are paying, you can even use that information to select what is the best supplier for me, because you know exactly what is the price of that ingredient in your feed formulation.
Yeah, exactly. So, and here we are coming back to we need to have connected systems. So from my perspective, I'm talking a lot about analytics and then the nutrient profiles, etc. But if we really want to benefit from what we are doing on the lab side, we need to make sure that we have got the right data together. Like you said, with the supplier. Then I need to connect my nutritional data with the supplier data so that afterwards I can run the evaluation in the right way. So therefore, we need, if you have a look on the data side, we need to make sure that what we have in the best case in our LIMS system, so the Lab Information Management System, that this one is connected to the ERP system so that we get those data automatically from the purchasing department, so that we have got which quantity was supplied, which quality did the purchasing department want to purchase. So then we can have a look as well if this target was achieved. If it was not achieved, then we need to get the message back to the purchasing department so that they can make up their claims. So if this is not working, then we have got a break in the information chain and we will not benefit. So then then we can do the best in the laboratory, but in the end, the company will not benefit. So therefore, this connectivity, so that we have got all the data connected and that all the people who need to take decisions have got as well access to the right data is really crucial.
Yes, and another thing that I would like to discuss with you is I see like more and more companies using NIR to evaluate, not only their ingredients, but also the finished feed. So in your opinion, how reliable and precise are current NIR systems under commercial conditions?
So as you know, Evonik has got a long history in working with NIR. And here it's again, come back to the basics. If you want to build up reliable NIR calibrations, you need to do the basics right. And the basics are here, or the starting point is that you have got a reliable wet chemistry lab, which is providing you reliable data as you need to make the connection between the reference data and the NIR spectrum. So therefore, reliable lab. So have a lab which has got a very small or high precision, small analytical error is really one foundation you need to be assured. Then the second step is select NR devices which are really capable. So this depends a little bit on the use case. So if you are looking for building up NR calibrations for water content, dry matter, or something like protein, this can be done with a lot of different NR devices. But if you want to be really precise, and as we talked today about precision nutrition, protein is not good enough. So then, as the animals, they don't need any protein, they need amino acids. So that's common knowledge. So therefore, we should have as well the possibility to analyze the incoming raw materials for their amino acid content. This can be done with the NR, but then you need to have highly capable NR machines, which are giving you good spectra back, which have a low error in themselves, so that one NR machine is producing the same spectra as the other NR machine. So therefore, we need to take care that we have got the right NRRs available, and then we can build up quite nice calibrations for really many different parameters. So as I mentioned, you can do it for the proximate parameters. You can use it to build up calibrations for the amino acids, for fatty acids. Lately, we have been even working on something like anti-nutritional factors like the trypsin jars in soybean meal, glucosinolates in rapeseed meal, canola meal. That's possible as well, but you need to do the basics right, and then you can build on that. And if we talk about then the quality of the final NR calibration, here it's important to have a look on the calibration fact sheets. So if we are developing NR calibrations, we always prepare as well these calibration fact sheets, as we are working according to the ISO norm 12099. So there the standards how to build up NR calibrations are nicely described. And it says as well that in the end you need to prepare these calibration fact sheets to make it obvious or transparent how well your calibrations are working. And there it's important whenever you are talking about the precision of the calibrations, ask for these fact sheets. Then you have got all the details in and you can see what error do I expect from this calibration. So this is then the best way to have a look.
Yeah, and you know, like when I go to the feed mills now, I would say more than 90% have NIRs. But now I see other feed mills that are trying to implement inline NIRs for, to analyze the incoming ingredients, but also some feed mills that are using to analyze finished feeds, and other feed mills are trying to do like inline for feed formulations. What will be your thoughts on that, or what? How do you see that technology in the future?
So inline NR is quite exciting technology. So we know in other industries, inline NR is implemented already for 20 years. So if we talk about, for example, the milk industry, or as well the crushing industry, so the soybean crushers, they use as well inline NR to determine afterwards the fat extraction, so that you have a look on the residual fat content to steer the extraction process. So if we have a look on this task compared to what we try to achieve in the feed mill, we see it's really different. So if I'm in the crushing plant, I will always crush each day, soybean meal. And I'm analyzing each day just in the soybean meal after the crusher, the residual oil content. So that's relatively easy, as I just have each day the same samples and I'm having a relatively small range of fat content. So therefore, I can build up easily reliable NR calibrations, which are working as well under this, let's call it stressful environment of production areas. If we compare this, what we try to achieve in the feed mill, we have got completely different challenges. Like you said, if we try to use it for incoming feed ingredients, each day we are receiving different feed ingredients. So here in Europe, it's really that you might have a long list of 50, 70 different feed ingredients which you might use the one or the other day in the feed mill. So therefore, it's not just scanning each day the same material for the same parameters. You want to have a long list of different parameters in different raw materials. So that's already a challenge. Then if we want to use it in the process to check, for example, the quality of the finished feed, then we are looking as well on different recipes. Or if you've got a feed mill, if it's your good case, then it's just one feed mill producing, for example, broiler feed. Then you've got the different phases. So then you need to build up NR calibrations for the different feeds to be able to analyze them. With regard to the parameters for the inline, at the moment we are limited to the proximates, so something like dry matter, crude protein, ether extract that can work. So therefore you can build it in, but what you can gain from it, for example, to recheck then your formulation is as well a little bit limited to compare what you would like to have. So as I said, animals don't need the protein, so therefore it would be great to have in the finished feed per NR as well the amino acids available. But unfortunately, we are not at that level yet, so that's currently not possible. So therefore, the direct feedback is not possible, so then we need to take the intermediate step and have a look on the protein, compare it to what we were targeting. So there, for sure, it can help to gain more trust in your systems. And what you can gain additionally always depends as well on how you're working and how good have you been in taking out or in controlling the variation. As this is then the most crucial part. As we discussed upfront, the biggest part of the variation in the final feed is coming from the feed ingredients. So the feed mill is adding just a small variation on top. So usually the feed mill is doing a good job. So therefore, the most variation is coming from the feed ingredients. So therefore, the focus should be on getting the variation in the feed ingredients under control, and then you are able as well to produce a stable feed over time.
Yeah, and I agree with that because, like if you are analyzing, even if you are analyzing the finished feed, and let's say even if you are only analyzing protein and fat, let's say if your fat is low consistently in your finished feed, that will tell you that you are likely overestimating the level of fat in one of your ingredients, right? So maybe that you can use that information to check what's going on, like with the ingredient analysis, or it might apply also to fiber, protein, and other nutrients as well.
Exactly. So here, as a kind of quality control at the end of line, it's, I believe, fine. So we can make use of the data. And it's not changing that we need to take care of the variation at the beginning, because otherwise we will see at the end that we have got a high variation, but then the feed is already produced. And in most cases, it will be sold or will be used, but then it's too late. So then we just learn that we have got high variation, but we would not like to see it at that point. So therefore, we need to take actions already upfront. Even if you have got an inline system at the end, we need to take actions upfront. So that we have got a stable feed. So then it's more or less a final control that everything is fine.
Yeah, I agree with you. And, we are also moving into the more automation, AI. So what do you see, the role of automation, AI, and a real-time analysis? What are the role in future precision nutrition and ingredient quality control?
So for sure, automation is not new. We have it already, since Henry Ford. We were thinking about how to improve processes, how to design processes that we are becoming more efficient. And over the years, we saw that automation was reaching more and more different areas. If we take, for example, the NR, it's a nice example because today, if you want to analyze a sample with NR, you do a little bit of grinding. If you want to use a ground calibrations, you put it on the NR, you press a button, and the rest is done by the NR itself. So then if you compare this with running it by wet chemistry, it's much more optimized. And if we then think about how to deal with the data, this can be nicely optimized as well. So you can have interfaces so that the data flow is not interrupted, that you take out all the manual steps. This is a nice example how you can automate as well then the communication between the different departments, etc. So here we can still benefit. So here, if I have a look on the industry, I think a lot of companies can become better in working with the data. So really putting up a LIMS system, connecting it to the ERP system, making it available to the nutritional department so that they can work really with their own data to estimate the safety margins by themselves on the data which they have. So here is great potential to get more out of the data. So this is nothing about artificial intelligence. It's just setting up the processes in the right way. I believe that artificial intelligence might help to improve at the one or the other point. For sure, it's not the solution to everything. So here it's always keep your brain on and think about what the AI is doing for you and if it's doing it as well in the right way. Otherwise, you might take wrong decisions as, it was not giving you the right answer. So therefore, we need to be a little bit careful here how to make use of it, but it has definitely potential. If we have a look in the feed mills, you mentioned already the inline systems. This is as well one way to get more automation into the feed mills or to get corrections in. If we have a look on modern feed mills today, at least the ones I know are already highly automized. So we try to exclude manual addition of feed additives as good as possible. So therefore microdosing units, etc., had been purchased by the feed mills over the last years so that you take out the manual parts or the possibility to do manual errors. So for sure, it's again an investment in microdosing, etc., but it's paying off. And as labor is anyhow short, we need to look as well for solutions where we can save the labor.
Mm-hmm. And also, like the other advantage of all those microdosing systems is like it does generate records, right? You know exactly, how much did you add in each feed formulation. When you add it manually, it's more difficult to generate those records. Yeah.
Exactly. And with manual work, usually mistakes are always happening. So nobody is free of mistakes. So therefore, when you have got manual steps in between, you need to think about as well how to deal then with possible mistakes, which might happen from time to time. And this is with automized systems much easier. So therefore, automation, especially for the dosing part, is as well a good investment.
And you did also spoke about using NIRs with, we are using NIR, and a lot of those processes in the feed mill have been automated already. I have been thinking about the future, maybe 5 to 10 years, if we can use an NIR in line that is evaluating grind size. For chickens, grind size is very important, and that NIR telling like a BFD in a motor of a hammer mill to slow down or speed up the speed, depending on the target particle size that we want to get. Do you also see those applications maybe for NIR?
Maybe NIR can give some indication as well for particle size. That's possible. But I think we need to combine it with other technologies. So camera technologies, for example, or laser braking. I don't know the right expression.
Yeah, laser diffraction or something like that.
Exactly. So this one is more reliable to come up then with the particle size. And at least I know there are systems already in the industry who are using this. So it's coming more from the flour milling part. So they have these systems already in place, but it can be adapted as well to the feed part, I'm pretty sure. And here, so this definitely can help to define particle size in a better way. And it's a good point to work on that. So some years back, we did an evaluation of the particle size in layer feeds, which we collected all over the world. And it was really shocking. So there, just maybe 10-15% of the layer feeds had been according to what you expect for a layer feed. The rest was really off. So some were that finely ground. In the first look, I did not believe that it's really a layer feed. So really too fine at all. And I was really shocked because for layer feed, everybody knows that particle size is really crucial. And then we received all of these samples and saw that the reality is, or what is done in practice, does not meet, was not fitting to our expectations at all.
Yeah, I agree with you. And I mean, that's the good thing about all these technologies too. Is like if you are using the same method or the same technology to analyze, then you can compare apples to apples. But sometimes, when we are talking about layers or even broilers feed, we say, oh, coarse or fine, but we don't really know what is the right micron size for that particular feed or ingredient. So, yeah, I agree with you.
No, and this, if we put it in the context, then again, of the precision nutrition, is really an important basic again. If we do not have the particle size right, if we do not have a well-developed gizzard, then we will run into trouble. So then we can have the best quality control for the feed ingredients in place, we can have the best recommendations, we can have a nice formulation, but if the particle size is not right and the gizzard is not developed, then we will not achieve the targets. So therefore, it's really having a complete look on all the different parts to decide then as well, where do we have got weaknesses, where do we need to improve, and what needs to be controlled. So yes. This is really crucial. So especially when we were thinking about new services, what we can improve in the industry, we were tackling over the last years this topic of the heat damage, for example, as we've got a lot of raw materials which are heat processed, like all the extraction meals, all the meat and bone meals, poultry byproduct meal, all have a heat history. And this is for sure impacting the digestibility of the amino acids. It can destroy certain amino acids. So therefore, it's a hot topic already for a long time. And then we were thinking about which parameters can we use to really analyze what is happening. So, and with this soya example, that's really great from a university point of view, academic point of view, because with the soya, if you start with the raw beans, you have got all the trouble with the under-processing, with the anti-nutritional factors. If you do then the processing in the right way, digestibilities are improving nicely, you get a good product. And if you then continue over-process it, then you will ruin the quality again. So therefore, it's nice to set up systems and define as well which parameters are reliable. And here, I had to realize that in sometimes the beliefs which we have in the industry are not holding true. So as I started to have a list on parameters which I wanted to analyze in the lab to identify reliable ones, for sure I had on the list urease activity, the protein dispersibility index, etc. And here we could nicely see that when it's about under-processing, then for sure having a look directly on the TRIPS inhibitors is much better compared to relying on some indirect measurements like urease activity or PDI or KOH or whatever. So because then it's clear, as long as you find TRIPS inhibitors, then the processing was not done in the right way. Even if urease activity is low, even if the PDI is on the low level, you still have high levels of TIA, something went wrong. And therefore, if you think about quality, it's always important to think about which parameters are really reflecting changes in the quality. And here we need to think about as well some beliefs we were building up over the years, if they really hold true or if we need to look for alternatives.
Yeah, and something that is really nice that you're talking about too is like when I was thinking about NIR, I will always think about like evaluating, soybean meal quality as you are describing, but also it appears that you are also using the NIR as you were suggesting, like to evaluate heat damage of other ingredients, like for example, meat and bone meal. And then it's nice to hear that you can look at heat damage and probably what I imagine that you do is like you adjust the digestibility for certain amino acids, maybe like lysine, cysteine, those amino acids that are more susceptible to damage, right?
Yeah, exactly. So heat damage, that's as well a really nice topic if you want to dig into literature. So because with the heat damage, what is happening there is usually classified or named like with a Maillard reaction. So Maillard reaction sounds easy, but it's a complete cascade of reactions which might happen. And it's really specific for the raw material. So if we have a look on soya, we will find different patterns compared to rapeseed meal or corn DGGs, as we have got different reaction partners. So in the Maillard reaction, usually everybody is talking about that the amino acids are reacting with the sugars. Yeah, that's one part of the Maillard reaction, but it depends as well already on which sugars do we have available. So then the reactions are as well ending up in different outcomes, etc. But for example, the fatty acids, they can take as well a role in the Maillard reaction, or the vitamins can take a role. So therefore, it really depends on the composition of the raw material you are checking. So therefore, you need to build up specific systems specific for the type of raw material. We started here with having a look on the soya, then we continued with the rapeseed meal and corn DDGs, and there we could clearly see that what we learned from soya needs to be fine-tuned, needs to be adapted to rapeseed meal and corn DDGs. And we were always running then in parallel digestibility trials to pick up what is happening in the animal, how does the digestibility of the amino acids change, what are telling us the parameters which are analyzed in the lab to really find parameters which are in close correlation to the changes in digestibility. So therefore, we were building up then the system which we call today the RED service to come up with a system which is reliably picking up these changes in quality which had been caused by this heat treatment. So because this is one aspect, but if we think about the sunflower meal, for example, for sure the amount of fiber plays a huge role. And this is for sure not, or is more or less independent from the discussion around heat damage. So then it's another aspect of the quality.
Yeah, and when you are looking like heat damage, you evaluate like reactive lysine, right, for some of the ingredients. Is that value the same for all the ingredients, or different ingredients have different reactive lysine values?
So in theory, if we have got a raw material without heat damage, then we are expressing it always as the reactive lysine to lysine ratio to standardize itself. So because then you are ending up with nice percentage values, and in a product which was not heated, we should see a reactive lysine to lysine ratios of something 95 or higher, so that more or less all the lysine is nicely available, is not damaged. So in principle, it can be used by the animal if digestion is working well, etc. Then if we apply heat damage, we have got the problem with the classical amino acid analytics that the early phases of the Maillard reaction, so the so-called Amadori compounds, they will be cleaved if we do the classical amino acid analytics. So as we need to cleave the peptide bonds, we are applying harsh conditions with these very acidic conditions to cleave those bonds for a long time, high temperature, and this will cleave as well the Amadori compounds. So therefore, the level of total lysine which we analyze is then overestimating the lysine which is potentially useful to the animal. As for the animal, the lysine which is bound already with these Amadori compounds is not useful, as they can't cleave this with the enzymes which the animals have. So therefore, the classical total lysine assay is overestimating the lysine value in heat damaged material. The solution had been to establish the reactive lysine assay. With the reactive lysine assay, we do the following. Before we cleave the peptide bonds, we do a reaction with methyl isourea, and this will attach to the lysine, so always to the terminal end, so the amino group of the lysine. As in the peptide bond, the first amino group is anyhow bound to another amino acid. So therefore, the terminal one is leaking out of the molecule and can react with the methyl isourea. And once this is done, we do afterwards then the cleaving. And when we cleave this, everything which reacted with the methyl isourea is then analyzed as homoarginine. So therefore, we are getting then which amount of lysine was able to react with methyl isourea, and this should be as well the lysine which is potentially useful for the animal. So therefore, you get a good indicator, and it doesn't matter at all what was reacting with the lysine. So that's the nice part, because when I started to have a look on this topic, the other way would be analyze, for example, specific Maillard reaction products like carboxymethylizine or furosine or something like that. Mm-hmm. So furosine is, for example, used in the milk industry as an indicator. But for us, it's not the right solution, as we would then need to identify which of the Maillard products are reliable indicators in each and every specific feed ingredient. Might be different in rapeseed meal compared to soya meal. And we saw as well that, for example, the carboxymethylizine is nicely accumulating over time with the processing. But for example, furosin is first built up and then it's reducing down. So therefore, it's a good parameter for milk, as they always apply only very short heating. But if we have a look on the values we get back from corn DDGs and soybean meal, etc., then we can see with continued processing, you will get a small furosin level. And then this is totally misleading because it's at the same level as an unprocessed sample. So therefore, you believe, based on furosin, hey, it's a good product. It's no signs of Maillard reaction, but it's not true. It's just that the furosin was already translated into something else. So therefore, you don't find furosin anymore. And that's really the beauty with the reactive lysine, as we are totally independent, as we are just looking on the lysine, and we have a look on which amount of lysine is still reacting with the methylurea. So therefore, it's a more or less generally applicable parameter. So therefore, you can use it in the soya, you can use it in rapeseed, canola, doesn't matter. And then it's just about which ratio is coming back. And for sure, if the ratio is dropping down, you have got heat damage. So then it's as well, from the interpretation point of view, really easy. And if we compare it on average, for example, in soybean meal, we see an average globally something like 88, 89. If we have a look on rapeseed meal, the average is about 8-9 points lower, so just in the range of 80. So means that in the average quality of canola meal, rapeseed meal, we see more heat damage compared to soybean meal. Just by, as it's a different product, the rapeseed meal is more, you can more easily damage it. So as it's a different product compared to soya. So therefore we see as well more signs of heat damage in soya.
It's time for our famous three.
Still delegating work to someone who hasn't adapted to AI? You don't need another assistant stuck in 2015. You need a remote AI specialist who can handle inboxes, research, reporting, ops, admin, sales support, and marketing, using tools like ChatGPT, Claude, OpenClaw, and automations. Wise VAs connects you with AI-trained Latin talent in your time zone at up to 80% less than a US AI hire. Schedule your free strategy call at www.wisevas.io.
That's really interesting. I need to read more about that, Markus. But just we are almost at the end of this podcast. But before we finish, I would like to ask you, maybe looking ahead, 5 to 10 years from now, how do you think precision nutrition will evolve in the animal and in the feed industry?
That's a good question. So, as the feed industry is usually a little bit slow in adapting to the new systems, I will hope that in 5 to 10 years, nobody is formulating any more diets using total recommendations like total amino acids. So we still see it somewhere at times here and there. So therefore, I hope that at that point of time, everybody is convinced and is using as well digestible amino acids in formulating. I hope that we will get rid of the proximates as good as possible, so that we will have contracts not running anymore on protein, but maybe running on lysine, maybe running even on considering as well the heat damage, so that once we identify heat damage material, that we will have as well the chance to claim it back, so that we get a better price for this damaged material. As today, this is not possible. If I get the damaged material, it was not in the contract. Contract is just on protein and ash and ether extract, so therefore, what to claim?
Yeah.
So therefore, I hope from the precision nutrition point of view that we move in that direction, that we get better contracts which are reflecting really the quality of the feed ingredients we are purchasing. And on the application side, I hope that we are moving further down the road, that we are targeting or formulating as well on what is important for the animal. So like I said, with the digestible amino acids, that we consider, for example, fatty acids instead of the ether extract. We have for sure a big chunk of work ahead of us for energy. So energy has got a lot of weaknesses today. So just think about starch. In today's formula, we just use starch as one parameter, but we know we can cluster or classify the starch as well in different categories like rapidly digestible, slowly digestible, total digestible, and then as well the resistant starch. Nobody's considering it today. And as the starch is as well bringing us all the energy into the systems, we should work as well on the energy, considering as well what we can do today with analytics. So the whole sector, carbohydrates, is not really nicely described today. So if we compare it, what we know on the protein side with amino acids and what we know on the carbohydrate side, this is really a big task to be solved to become more precise. So I hope that in 10 years we know more how to make use of what we are able to do with analytics, so that we translate it as well into the feeding concepts, building up recommendations, for example, for something like the non-starch polysaccharides. So we can analyze it, but today we are missing recommendation levels. So at which point is it getting crucial? When do we need to adjust it? At the moment, we don't know it. So there's still a lot to do.
Yeah, I agree. And I don't know why people still continue like formulating in total amino acids. I made like an exercise with a good friend in a company. And I told her, you already have all your digestible values. Why are you still putting constraints in your total values? Because when they use total, what I was telling her is like you are assuming like all the ingredients have like the same digestibility of amino acids. And she did the exercise, and maybe like an hour later told me it's way easier to formulate on digestible than in total, especially when you got like many different ingredients and those ingredients have different digestibility values for different amino acids. So hopefully, like people moves to more digestible in the future. It's gonna be easier for them.
If you work on total, you need to use as well recommendations which are based on total. And if you come up with recommendations, you need to consider then the differences in digestibility. So therefore, you need to build in some safety margin, just to compensate that if somebody is using less digestible ingredients, you need to compensate via the increased requirements. And this is really a way which is just making the feed more expensive.
Yes.
So I did a similar exercise like you. So then I could see easily you have got difference between $3-4 per ton of feed if you formulate a diet based on total recommendations or based on digestible recommendations. And you will just over-formulate if you're using highly digestible ingredients like soybean meal and corn diet. Then you are overachieving your target based on the digestible ones. And this can be compensated once you use the right system.
And that's what she told me. Is like now I'm saving like $2 to $3 per ton. That's a lot of money. That's money that can be used, like to make improvements in the feed mill. I'm glad to hear that too, Markus. Well, that concludes another episode of the Feed Science Podcast Show presented by Weisenetics. Thank you for joining us today. Don't forget to subscribe to stay ahead on future episodes. And if you enjoyed today's episode, please leave us a comment. Thanks, Markus, and I hope everyone has a blessed day.
Bye-bye. See you. Thank you for having me.